Hi guys, today I'm gonna give you a short review of the paper Wav2Seq by ASAP, CMU, and Cornell University. As we all know, in the Wav2Seq pre-trained model, the target is in the training is the quantized vectors, and it uses the contrastive loss. While Hubert was developed based on after the Wav2Seq 2.0. The authors used the MFCC cluster IDs as the training targets, and as you know, the loss has been changed from the contrastive loss to the CE loss. And I want to stress this. So the MFCC cluster ID can be reviewed as a pseudo audio IDs or pseudo audio units or IDs. And in this paper, the authors moved one step forward and they proposed the Wav2 sequence. Instead of doing the pseudo audio units in the Hubert, they propose something called pseudo subword IDs, and they still use a CE loss. And the benefit of this, as claimed by them, is that they can apply low-cost second stage pre-training, which means they do not that many transcribed data for tuning the decoder or fine-tune the decoder, because they claim that by introducing these type of subword IDs, they could introduce some type of language stuff into their pre-trained model. Okay. Talking about the performance, as you can see that they compared their system on the partial size deliberate speech task, and you can see when you only have 10 hours of data, the CTC would get 36.5, and if you're using the sequence to sequence model, which I think it's like a it's like the about 5 years ago, something like the sequence to sequence. You can regard it that as a transformer without self-attention decoder. Okay. The Hubert baseline is worse, but when they using their Wav2 sequence, the performance increased greatly. And eventually, when they're using a pre-trained model from Hubert, they get better results than the CTC model. And for the transducer, I think they're talking about RNT here. It's slightly worse, but it's still better than the Hubert baseline. And they also compared results on the 100 hours when using the transformer decoder. Also, they compared they try to use the speech embedding they learned for other speech-related tasks. For instance, one task they did was spoken name entity recognition, and it's better. They also tried on the speech-to-text translation. It's like when I speak in English in audio, what's the translated text in French? That's better. All right, I'm gonna stop the short review here. If you're interested, please watch our long review. Thank you.